yesterday, where there was another big event. So let's just start off with introductions and maybe talk a little bit about what your company, what your solution does, and we'll jump into it. So I'm TM Ravi. I run an incubator and a funding entity called the Hive, which focuses on data-driven businesses, across various application domains.
My name is David Sonnenschein. I work for SAP, specifically responsible for early stage company enablement of our big data product, HANA.
My name is Adam Smith. I'm the VP of Product at Metamarkets. And my first, experience with big data was at Google as a product manager building our click-through rate prediction engine. So that sort of led me to Metamarkets and sort of this space.
Hi, good morning. My name is Guido Schroeder. I'm the SVP product at Splunk. Splunk provides a platform for machine data analytics. So machine data is pretty much everything that is produced by your IT infrastructure, but can be sometimes also beyond IT.
My name is Kevin Foster. I'm with IBM. I'm part of our big data product engineering organization. I spend nearly all my time working in the stream computing area.
So good. Let's Kevin maybe start off with you and just kind of talk to us a little bit about kind of what do you think of as big data?
The shortest definition that seems to work pretty well for me is you're going to need a cluster. If it works on your laptop, I don't think it quite fits the definition of big, and you can go 16, 32-bit or 32 core boxes, but usually it's some volume of data and some complexity of algorithm that's going to push you off into racking lots of boxes. And what that data is and what you want to do with it's going to vary by industry, of course.
Any other thoughts?
On the big data question?
Yeah,
or
anyone
the big
else?
Data
Anyone else? Different types of data, structured, unstructured?
The question open for the rest of the panel too.
Yeah,
so maybe I start with something provoking. Yeah. I don't like the term at all. Yeah, it's confusing, it's overused, and now pretty much everything turned to big data. So I don't know how much identification or differentiation it provides. Maybe a better term would be difficult data, and there are different reasons why data can be difficult. I mean, volume is one, but it's not the only one. Yeah, I mean, everybody probably knows about the V's, whether it's 3 V's or 4 V's, so I mean, Splunk, as I said before, is very much focused on machine data. We think or see that this is actually a very fast-growing segment. And very large chunk of big data. The reason is probably that machines, of course, can much more easily generate data and spit out data than humans do when they are creating documents. And we think it's interesting for a couple of reasons. I mean, one thing is it contains kind of very interesting and comprehensive record of what users are doing in a system and how your IT infrastructure behaves. And it's also pretty interesting because it's quite complex. I mean, typically, it's not very well structured, which I think is one of the key characteristics that we are seeing that makes data really difficult, that it doesn't have, a neat structure that you can fit into an RDBMS. But often there is a, high degree of variability, and that creates some challenges how you actually, use that data and make some sense out of it.
So Hadoop has captured a lot of the imagination of the people who are doing big data, especially in the kind of Web 2.0 space. And Hadoop is generally known as a batch processing system, especially sort of MapReduce that does the processing on top of it. What's really the driving need for real-time, and why isn't it that Hadoop meets that needs?
Sure, that's a big question, of course. I mean, in terms of the volume of data, like we were just talking about, versus the sort of the insights and the usefulness of the insights in a timely manner, the real-time aspect is really about being able to slice through that and do something in a much more constrained time frame or pull things together. I mean, I think the previous speaker talked about sort of the ad hoc aspect, but taking it even further such that you actually have insight and action that can occur, or sense and response that can occur. And so where Hadoop, you know, you could easily say, will eventually spit out the answer, and I don't mean that in a pejorative way at all, but I mean, it'll give you the answer. But if you need the answer in a time frame that the action is, that from it is valuable, then real time becomes the more important angle.
Adam?
I mean, we think of sort of real time in sort of two ways. There's sort of real time fast and there's real time live. Fast is, you know, you want to ask a question, you want to get a response in a sub-second time period. That's sort of how we measure our systems. But live is sort of, you want the data that's just happened to be in that system and to come out at a sub-second. So we think of sort of real-time ingestion versus real-time serving. And those are the two ways. And Hadoop has solved the scale problem. But I think that the new challenge for a lot of companies is how do you solve the speed challenge, both getting it into the system and serving it out to the customer.
Yeah, I think the live and that time to decision is a key thing. Sometimes instead of real time, and some portion will think, oh, are you talking the microprocessor stuff, where we're actually counting how many instructions? I think for business, it means just in time. And if you're a website selling music, maybe 10 milliseconds is all you can afford to do fraud detection on that purchase site. Or you're a bank doing single sign-on, and you got a 100 millisecond budget for scoring that attempt and trying to decide if this is identity theft or not. But if you're a telco and you're trying to SMS somebody and say, hey, if you prepay, throw some more money in your account, an hour might be fine. So there's the just in time for the use case aspect. And of course, stock trading, you know, if you're going to be late, stay home. So every industry is going to have its time thing. And so that real time is going to depend on the data type and the algorithms and the intended business result.
So similar to what Adam said, you know, we see with our customers two aspects about real time. One is really the latency between the time an event is created and it shows up really in our system, you know, that you can, you know, analyze it and report on it. So that's one. And you know, in many use cases, I would say our customers are okay if they see the event in their reporting on a dashboard showing up 15 seconds or within a minute, you know, after it actually has been created, and that's good enough. Yeah. And sometimes, you know, they have a human operator sitting in front of the screen that's reading something of it. Sometimes, you know, it could also trigger an event that is connected to some sort of other machine and system that would actually process it. So that's really aspect number one, the latency between an event occurring somewhere in a system that generates that data and then showing up on our side in any sorts of analytics. And the other aspect is, you know, really, I would say the interactivity. Yeah, I mean, he called it live. I would call it interactive type of analysis on a large set of data. And the way how we are dealing with that at Splunk is that we're kind of streaming data back into the results pane of a search. Yeah? So, you know, sometimes a search might take quite a bit of time if you have millions and tens of millions of events, yeah, but you can gradually or incrementally build a result set on a screen, and that provides actually a very interactive type of experience for the user when they can start with a search and then gradually refine it before waiting for a long-running batch job. And that's a good way to deal with you know, the problem of having a large data set.
You talked about sort of human being, you know, one use case being a human being kind of being the consumer of data, and hence it needs to happen in human time. What about the other use case of a machine being the consumer of data? Any thoughts on that?
So a number of our customers in sort of the DSP space and the advertising space are doing sort of machine learning. And what's interesting is when you build those systems, you have to keep track of them because oscillation, there's all sorts of problems that can happen. So they actually use us as diagnostics. So even though it's machines that are doing sort of the work, we're actually giving them a tool to make sure everything's going okay. It's sort of a button to say, okay, hey, stop, something's wrong here. So a lot of the machine stuff is also tied to human beings because the amount of transactions that can happen and the amount of money that can be lost is so large that they just don't trust the systems and the new code that they're pushing to actually be successful. And so I think that the two they're different, but they're also very connected. I don't think you can build something that machines can watch and human beings can't keep track of.
I think the other thing, because it's big data, you're not restricted to waiting for someone to have an issue or complain and then start analyzing that person. The applications that IBM is working on, we're going to analyze all the traffic for all the customers, whether it be 25 million or 175 million, in case one of them calls. So it's big data. It's just iron. The CPUs aren't that expensive. They take surprisingly few. 6 or 8 computers, I can monitor the telco call volume, call usage behavior on 170 million customers in case somebody calls. So why wait? Besides, if you only start looking at their issue after they called you, you don't even have the data. So if you can predict, and then if you can combine that with a prediction that says, ooh, Kevin Foster just had 4 dropped calls in the last 2 hours. Pretty high probability he's calling about that. Why don't we just route his call to those texts or that voice response system? We could easily save the price of an entire call center if we can anticipate and understand why someone's calling us.
Kind of going beyond kind of the hype of that you guys talked about big data, we've had OLTP systems which have been kind of address real-time needs. We've had sort of DSS, decision support systems, that have dealt with large amounts of data. What's really kind of driving the need for a new type of system? Why can't we, many people talk about high-frequency trading. We've had high-frequency trading for a long time, and many vendors like Oracle and SAP and so forth have addressed those needs well. What's really new about the requirement, the need in the space?
So I mean, one of the biggest differences we are seeing at Splunk is, not imposing a predefined schema on the data. Yeah, and let me give you one example where this is relevant. It's, for example, with security. Yeah, so I mean, for a long time, security has been dealt with systems that are called SIEM, security information event management, and they have a concept of, kind of data reduction, where you actually sample data from your network devices, from your firewalls and whatever, kind of reduce it and put it pretty much into a relational type of environment, and then run analytics on top of it. And that simply doesn't work anymore. One reason for that is that the threats are constantly changing, and pretty much all information that's out there can become security relevant. You don't know a priori, and that kind of requires the system that is much more flexible in terms of ingesting data without a predefined structure. And so at Splunk, we actually don't have the concept of a schema into which we are loading the data at all. We pretty much behave like a tape recorder that just collects the data as it is, indexes it very deeply, and then we have a concept that we call schema on read that actually applies a structure to the data when you analyze it, and that provides a lot of flexibility to run all sorts of analysis on the data after you have captured it. And I think that's a big difference, and probably occurring in many other use cases where you have a large variety of data that doesn't fit into one schema that has been defined by an administrator.
So Splunk was extraordinarily innovative in avoiding sort of big agent frameworks and force-fitting things into schema, and hence being able to deal with sort of a lot of unstructured data. David, any thoughts on this structured, unstructured, sort of the definition of big data sort of being driven by the types of data that you can ingest and how fast you can ingest it?
Well, I mean, I think actually everybody's already put some good examples of the fact that there is certainly benefit in figuring out how to handle the unstructured data and the flexibility that it gives you and the opportunity that it gives you. Okay, SAP, we're in the enterprise space, a lot of structured data. we see a lot of the combination now of structured and unstructured data really being an interesting thing to take on. And part of that is sort of the more compound nature, the more complex nature of the analysis that you want to do. And just kind of a simple example is that I think everyone's kind of heard of is the concept of sentiment, you know, from a social networking perspective relative to sales, returns, product development. I mean, all sorts of things where you actually know what your idea is and your plan is, but you want to enhance that with a much larger set of unstructured data. And again, you want to put that in a time frame that's usable, right, and actionable.
Is there a kind of a point of view there also that in enterprises, people have a lot of legacy structured data, they're used to certain tools like SQL, and so there's a kind of a need, especially in the enterprise, to have databases, architectures, that's some sort of a mix of both?
Well, I think what I think is clear is that sort of the time to value from any of these tools is if you can leverage what people really already know. Standards, SQL is a great example. But I don't want to take away from some of the other approaches. I mean, I think the tools used appropriately and for their intended purpose, you don't necessarily need to have the standard, you know, thing that everybody knows. But yeah, certainly that combination of standard-based interfaces and standard-based approaches and tool sets means that you have a much wider group of people who can benefit from now this big data concept.
So SAP, you know, has the HANA, if I may characterize it, as sort of uses in-memory, kind of a large in-memory sort of architecture. Can you talk more about sort of why that's good, why you've chosen that?
Well, sure, and again, anyone who's done, you know, the more traditional, you know, data warehouse type work and all of that will get this, I think, pretty quickly. One thing about HANA, and there are a couple things about HANA right off the bat. One is that it's primarily a column store, though it certainly supports column and row store. And the other is that it's 100% in memory. It's designed from the beginning to leverage, you know, very high I/O interconnectivity, in memory, all of those aspects, right? So what it removes is the need of that sort of batch or that pre-aggregation, pre-calculation approach. It allows you to take your data and load it up and then project it in lots of different ways at runtime and not have to do as much pre-definition of what you're trying to do. And that also allows us to do, I would say, a lot more of those complex or compound type queries, results, and answers.
That's assuming the data set fits into memory.
Yes, it does. It assumes that.
Do you want Adam
I mean,
talk
yeah,
about
so this
different
is
architectures?
This is primarily what we do. Our system's called Druid, and in our space, in sort of the real-time bidding, we sort of see that, you know, right now it's extremely important. Last week was kind of important. Last month was relatively important, and then there's a certain point you hit a drop-off. And so, you know, as you build in-memory systems, as you guys have at SAP, it's just a matter of cost. How much are you willing to bear in memory? Now, SSD is coming out, and so things are going to get lowered and better. But there's physics. There's hardware you have to put out there. And so what we've tried to do is figure out what's the right amount of in-memory for that interactivity, and at what point can that slow down and be an okay. Because there's, in the advertising business, there's quarterly reviews, there's yearly reviews, but there's a lot of day-to-day activity that they need to basically query a system and not know exactly what they're querying about until they dig into it. And an example for us was one of our publishers saw a whole bunch of sites just go down. It saw a blip in its revenue, and as it dug in, it realized that GoDaddy's DNS had gone bad, and that was the problem. So they went and called all their customers and said, hey, you're not showing up on us anymore. This is a deal that we made. And it was, their customers were so happy that they had somebody who was really cared about them, and it was because they had that, like, by the second activity of watching what's going on and being able to dig into that. You could not have a pre-done report of tell me who's gone down in the last second, constantly polling your system.
So just one question, and we'll come to I think indexing type approaches. But so what happens if you have a miss? So it's not in memory. that you kind of fail to meet the real-time sort of commitment, or is it sort of best suited for certain use cases? Just kind of whether it's a Druid or sort of open source kind of like MongoDB-based type approaches or SAP HANA.
I mean, for our architecture, we have the idea of sort of a hot cluster, which is sort of all in memory. There's no missing, nothing goes to disk. And then this idea of a cold or semi-warm, where some's in memory, some's not. It's just a matter of what's being paged up. So to our users, what we say is, hey, we'll guarantee you sub-second response time for this sort of time period. After that time period, we're going to do the best we can to get you that answer. And if that doesn't work for you, hey, we can move the line. We think it's a month. If you think it's 2 months, if that's what works for your business, great, we can move it. It's just software.
Guido, Splunk, again, was very innovative in sort of indexing all the data as it came in. And
so, you know, I'm not sure if I want to highlight the indexing part of it, yeah, but we took definitely a different approach in terms of, you know, betting on commodity hardware. Yeah, so we don't, you know, require a big box with lots of memory. And I think, you know, we can perform with that very well. So we, you know, scale horizontally out. With commodity hardware, we have everything on disk. The only thing that puts it in memory is what the OS potentially caches. Yeah. So we delegate a lot of things actually in the architecture to the OS, but we don't have our own cache. We share one thing with HANA, which is also a columnar type of storage that we built into our index. And that gives us, I would say, still extremely good query performance. So I could show you on, you know, a commodity laptop, a query running on a large data set, also not pre-aggregated, but you know, the example I have there is a 150 million record data set from the FAA. That's all flight movements in North America since 1988. And I can actually run on my, you know, iCore 7 machine an aggregated report on that data set in 2 or 3 seconds. Yeah. And that doesn't create much of a hurdle. I mean, sure, our system would also benefit, yeah, if you know, store it on an SDD. But you know, to be frank and clear, we often see also scenarios that are actually more limited by network bandwidth, yeah, than you know, actually the latency of a spinning disk or anything. Yeah, so there are quite a few you know, architectures where, you know, really the transport of events from the place where it's generated, yeah, to the analytical system, and then also to the end user becomes more the limiting factor than anything else.
So in the case of Splunk, you're saying no special hardware needs, no kind of special scale-out needs, use what you have.
Yeah, I mean, you need to understand our philosophy. Our mission is to make machine data accessible, usable, and valuable for everyone. And if you require a $100,000 or a $400,000 investment first, yeah, with a large box, I think that becomes very prohibitive. Yeah, and you can start basically Splunking and solve real-world big data problems, you know, with a very small license and actually commodity hardware, and that's what a lot of our customers are doing. You know, we have this viral type of adoption model. You can download a free license from our website, and then basically can get started on a very simple, low-powered machine. And that's what a lot of customers are doing, that they actually start with a free product, see the value, and then put it into a larger environment.
Kevin, other architectural approaches to real-time big data?
Yeah, I think in some ways we make a mistake thinking that big data is only BI, and it's only a model. The only possible model is a store it then query it model. IBM certainly has a lot of products for store and query, SQL, non-SQL, columnar, you name it. But if you really think about it, there's a couple of inherent problems with that. Great for history. What happened yesterday? What happened last week? What happened last month? Can I understand history? You know, those who don't study history, doomed to repeat it. It doesn't really help you with the now. I mean, the act of storing it for something else to turn around and pick it up to query it. Number one, you've introduced latency. I don't care whether it's spinning disk, SSD, memory, or whatever. You've got a two-step process already before you get back to holding a piece of data that you had in your hand in the first place. So if you buy Starbucks and someone gives you some bills as change, you don't stuff it in your wallet and then query your wallet to see how much change you got back. When they hand you the data, in this case the money, you look and say, hey, you're $1 short. You didn't have to store the information you were getting to actually come to a decision on the data when it arrived. So I've never seen any real time where we did not store. We always store, and with economies of hardware, the answer is store more than you ever thought you could before. But for real time, both for speed and truly for the efficiency, which takes longer, holding the bill and looking or pawing through your wallet. I don't care if you have parallel out the wazoo, it's still going to take you longer to paw through your wallet after you put the money in versus when, and then taking it back out again. So why did you do that?
Guido?
I would like to add maybe two more comments and facets to the discussion. I mean, when we are talking about deployment, I think one interesting trend or possibility is certainly also to put things into the cloud. Yeah, so Splunk released, last fall in August, a cloud-based product, Storm. I think the nice thing about a cloud deployment or architecture is certainly the elasticity that, a customer could benefit from to not, own a large chunk of hardware, but, kind of temporarily scale it up without...
both on-prem and...
Yeah, we are on-premise as well as in the cloud. And then I would also like to comment on Hadoop. So, what we are seeing is that, Hadoop certainly has its place, but we have seen customers being mostly successful using it really for cheap batch storage. Yeah, and that's pretty much it. But we see a lot of, I would say, difficulty and struggling, to get some real value out of Hadoop in terms of analytical projects.
Let's ask Adam. So, there much of, there's been a lot of kind of big data washing of traditional existing architectures. A lot of the momentum in big data is captured by Hadoop, and there's just so much energy, and even the large vendors are sort of all aligning behind it. I guess the question is really, how do you see sort of it playing out, which is kind of cheap, cost-effective, open source based, whether Dremel, Druid, Drill, Pragel, S4, you name it, versus kind of proprietary sort of systems, which are going to be kind of turnkey systems, easier to manage, easier to deploy. A large company like SAP or Oracle standing behind it. Adam?
I mean, I don't think our industry is any different from anybody else's in that there will always be sort of a open source movement to sort of see if enough people have the same need that can get together and extend it. So we open source Druid because we realize that this piece of the infrastructure is important for us. It's so important for us that we need other people to help us grow it and extend it. So we put it out there in the world, and that's why a lot of big companies put out open source software, because they realize that even their needs can't push it as far as it needs to go for themselves. So I think that's going to happen, but there will always be proprietary systems and software that go out there. I think in high frequency trading, I don't think anybody's who builds a better mousetrap is going to open source that. It's just that's not the nature of that business. Hadoop is not like a Hadoop versus other things. Hadoop, it's got a lot of components that I would be shocked if not all of us at this panel use in some way, shape, or form. The question is, how do you extend that, and how do you solve problems that Hadoop doesn't? Hadoop doesn't solve the problem of I got 100,000 events per second coming in, and I know the business logic of what I want to do when I see that data. Hadoop's not the one that's going to give you that millisecond response time. So I think Storm's a really interesting we've looked at. In fact, we think that ingesting these high volume data in real time is actually going to reduce processing speed. So we actually see Hadoop potentially kind of dropping out of the picture at that side of the equation. But again, this is where you're just going to see over time as we go to market, as these go to these verticals, which is going to push the number of people to get together and collaborate.
Interesting. Thank you. I think we'll take some questions now. If there are people with a mic, perhaps, or go ahead, just stand up and ask your question. Oh.
Thank you. Yeah, thank you. Great panel, great discussion. One of the questions I have is, what is the next gen as far as data science, data mining, big data? Is it better, like the next 5 years, for example, is it better performance, better scalability, better tie into more complex machine learning? What is it? The next 5 years, what would you predict? Thank you.
I mean, this may be a small thing. I don't know if I go 5 or 10 years, but something that's really top of mind for us is people always say, I want a bar chart that shows this relationship. And what you really want to say is, I want to see relationships here. Tell me what the right way of diving into that is. So I think we look at a lot of visualization of data, and I think that what you're going to see is systems that basically guess what's the right way to evaluate relationships, as opposed to you just finding it ahead of time.
Go ahead.
I mean, I think the algorithms and the techniques are developed, and there, don't expect too much progress there, but it's really about making it applicable. Yeah, and that would be my concern and focus. To make sure that all the smartness we have now and understanding in algorithms, really you get the horsepower on the ground. Yeah, and that's what we try to do, to kind of bring it to the masses, yeah, and it doesn't require necessarily a data scientist to do data science.
So to characterize a lot of action in data infrastructure, data science, but it's got to be kind of have real world value and applications.
Yeah, I mean, I would just add to that, because I agree with both points here. It's knowing how to visualize it and work with it. It's basically making it useful. It is the bigger now challenge. So, and usable. And by usable, I mean both, that it's useful, but also that anyone could get at it and benefit from it. I think that's an absolutely big part of sort of the next wave. And I don't care if it's putting it on the mobile device and that has its own constraints, or if it's certain visualization or predictive analytics algorithms, as Guido said, they exist, but how easy is it for someone to use them for their benefit?
Got it. Another question? Go ahead. I'll repeat the question.
Hi, I'm Arun Das. I'm from Dream On Demand LLC. It's a business intelligence software for small businesses. We're in a stealth startup. My question is actually, I don't know how would I, put a shape to it. It's like when you have a mix, you have real-time big data, right? You have real-time big data and lots of big data sitting in your disk on premises, right? If I want to derive a decision, not really real-time, but near real-time or pretty close to real-time, maybe an order of magnitude higher than the actual real-time, which is zero time almost. In that case, as you mentioned, Hadoop is not really the best example for extreme real-time. So for the mixed case, when I want to mix the real-time data with the data sitting on premises, what would be the optimum approach?
Got it. So some sort of mix of streaming data, real-time streaming data coming in, stored data, and kind of near real-time decisions. Go ahead.
Yeah, I think a pattern I see the most is I'm going to use historical data to better understand how the world works, right? I mean, I'm going to derive models or rule sets or something based on data I've gathered, based on things I'm observing. But then I want to use that newfound knowledge as the world happens now. So, what does an infection in a 2-pound preemie baby look like? If I don't know what that looks like, then monitoring for infection doesn't do me any good at all. What's a good opportunity to buy and sell stock? Well, if I don't have some kind of statistical, some kind of evidence-based model, I can, streaming without history is lightning fast but wrong. History without streaming is always being right but always too late. So a combination of the history for the model purposes, the contextual, as well as that speed of execution. You might actually build your models as you go as part of the streaming as well. Takes a little while. Got to get a little bit of data in there. As we heard earlier this morning, not a whole lot, though.
I think the most clear example for me is seasonality. You're going to see a big bump on your revenue or impressions. And again, I'm in the advertising space, so that's what I look at. And you're going to go, what happened? And you go, oh, it's Easter. And Easter bounces around. Easter doesn't bounce around, but you got to basically look at back in time. Is this unusual behavior to what's coming in streaming? And that's something that we focus a lot about, because that's sort of what happened a year ago, and then adjusting for holidays that bounce around is something that we think a lot about. So that's basically your point is you got to know what's normal in history, and you got to know when you're varying off this second.
Another question?
Thank you. The question that I have is kind of philosophical, and Guido told that technology is ready for a big data explosion, and we already have algorithms, we already have tools, we already have Hadoop, Impala, Druids. So, but in reality, not too many enterprises they adopt big data and they don't start implementing big data projects, and many of them claim that they're lacking big data real-time analytics, but in reality, not too many of them do some active steps in this direction. So the question is, what do you think are the major bottlenecks that prevent enterprises from doing these major steps into big data projects implementation, whether it's a lack of education or it's cost of hardware or commodity or lack of engineering talent? What do you think?
Got it. David?
Well, yeah, so as a first response, I mean, I've got very good news for you in the sense that our HANA platform is our fastest selling product of our 40-year history into our enterprise customer base. So it's not just, fluff or hype that people are excited about big data in the enterprise. They're buying big data solutions. Now, that said, I think it goes back to the point I was trying to make earlier, which is making big data, or real-time big data in particular, usable, right, consumable, is a big deal. And so some of the other approaches to big data, while sufficient or capable, if they're too complicated or too different or too extreme from what the enterprise knows, you have a lag. It's not that you would never get there, but you have a lag. So I think that is part of the holdup, part of the bottleneck. But like I said, I think we are seeing that shift move much faster than we would have thought, actually.
So I mean, projects are difficult today. Yeah, there's a pretty high rate of failure, and it also requires a very significant commitment. I mean, Hadoop projects, and especially if you want to build really a complete solution around it, require really a commitment to stitch a number of different things together, and it's not that fast. Yeah? I think the root causes why there is a high rate of failure are probably two things. One is lack of skill. Yeah, I mean, this is a still pretty exclusive club of people that know how to leverage this entire zoo of tools and technologies that are out there. And on the other side, I would say a lack of integrated end-to-end solutions. Yeah. SAP with HANA is providing one. Splunk with our enterprise platform is providing one as well. That provides really an end-to-end system that includes the data collection, the processing, and also the visualization and access for the end users.
I'd say also there's a different, depending on the group you're working with. For real-time especially, the IT folks have said, hey, we've always been successful store and query. Why does anyone actually need it that much faster anyway? Their business peers know exactly why they need it sooner, but they don't know necessarily. The business folks don't know what to ask for, and the IT folks don't know to offer. So the least successful meetings I ever have traveling are with one or just the other. The most successful are when they're in the room together, and then there's usually a period of talking and debating and discussing and imagining, and often though the implementation can go faster than the decision making. Had a customer in Malaysia. We did a 1-week POC in July. They talked about going forward, made a decision to go in November, kicked off a project that went into production in early January. And it's actually doing real-time marketing to their telco customers as early as 2 months after start. So it happens, but it's new. And people need to learn. And every single organization has to go through the learning curve. They have to learn.
Let's take one more question.
I was going to say really fast. A lot of people also think that this isn't that hard of a problem. They can do it themselves. And so they can go get some open source software and they can get a MongoDB together and they can put a front end on top of that and no problem. I can get a report going within a week or two of engineering time. And then I say, okay, call me in 3 months when you've given up. and then they call me usually a couple months into it, say, okay, we'd like to have a plan B, and then by the time we actually have a conversation, they've totally given up on devoting their engineering resources towards this problem. It's just hard. And the problem is it's a hard technology problem that has to be applied to specific business cases. And so those are two different types of people that have to be brought together, and that's what I think our companies are trying to do, which is how do we take these sort of very high-functioning engines and build a vacuum cleaner and a blender and really put them to real applications that people will buy and use.
Question?
Yes. Ooh, goodness. From a mic that didn't work to a mic that is super powerful. I'm Linda Sharp with Religence, and I wanted to ask a kind of a circular question. You're talking about real-world value, business results. I think that's what you all are saying you'd like to get to. Gartner has come up with a formula. They're calling it PETS, which is kind of cute. Process-enabled technology and services. I'm wondering, this is the question, do you see process beginning to affect big data? I haven't heard any of you talk about that. Business process. Thank you.
Very interesting question.
Well, I'll take a short, quick answer on that. Of course, business process is core to SAP's long history. And so we are seeing sort of macro and micro business processes having an influence on big data. The idea that you would branch a process based on signals that are coming through big data is absolutely an area where we're seeing activity. And I use that very broadly, but I think it is a very important aspect. It becomes more important as you have the tools to do something with it. And I think that's part of why you weren't seeing it so much before. You always needed a dialogue with a human to move a process to its next step to some degree.
I might be taking a slight jump off of that, but for me it's workflow and advertising. Literally deciding to spend you this much money, putting together your creatives, figuring out how you're going to do your targeting, getting that into the system that goes and does it, make sure it actually does it, getting back the results. It's just a huge human process problem with a lot of Excel being used in strange ways. And so a lot of the challenge is how do you help those folks use underlying technologies that'll make that process faster without having to dive too deep into knowing exactly how that works, because it's not something that too many companies, or at least our company, is focused on.
I actually don't see that much of a gap between big data and processes. Actually, much of the data that we are seeing is coming out of operational processes of companies. I mean, just an example, telco provider, Cricket, you can read about them as a customer case study. Their core process is cell phone plan activation, and they need to know in real time, what's the throughput in this process. They need to see, what product they actually sold to customer and things like that. So a lot of the data that we are seeing is absolutely coming out of operational processes.
Do we have time for one more question? No. Okay, great. I thank you all, the audience, and thanks to all my great panelists here.